Sequence and series, let's start off with some definitions. So what is a sequence? There's a subtle difference between a sequence and a series. So a sequence, also known as a progression, is just a set of numbers and they follow a pattern. Now a series is when we chuck a plus sign in between them all. A, conveniently, we use to represent the first term in the pattern. And then for every other term after that, we just generally go T with a subscript of whichever term it is. So technically, A could be written as T1. And if we actually want to find the value of the series, so all of them added together, then S would be the symbol we'd use rather than T. So for an example, here's the formula that describes a pattern, n squared plus 2. They want us to find, well, what would be the fifth term? Now, it's just a substitution question. Substitute 5, we get 27. Is 42 part of this pattern? Well, let's solve it. Is it possible for n squared plus 2? Because the thing is, n has to be a positive integer. And when we solve this, we get n's the square root of 40. Well, no, we don't know what the square root of 40 is. That's not a positive integer. So no, it's not part of this pattern. Okay. Then we've got this thing called a recursive formula. And that's where we define a series in terms of previous terms. Most famous of them all probably that you've seen would be the Fibonacci sequence, where to get a particular term, you add the previous two terms together. So it designates how does this pattern start. So I'll tell you what's the first one, or maybe the first couple. And then the actual expression to then generate all the other ones after that. So here's one. First four terms, it's defined by, we're going to get the previous term and simply add 3. And the very first term in this pattern is 4. So alright, that means the second one would be 4 plus 3 is 7, the third one would be 7 plus 3 is 10, and the fourth one would be 10 plus 3 is 13. Lucas numbers, very similar to Fibonacci numbers, you'll notice, because you do add the two previous ones. Subtle difference between the Fibonacci sequence, I don't know if you recall the Fibonacci, but the first two terms in Fibonacci is 1 and 1, whereas in the Lucas numbers it's 1 and 2. So the first term is 2 and the second term is 1 though. So in a slightly different order. It doesn't go 1 then 2, it goes 2 then 1. So what does that do to the pattern? So we start with 2 then 1, add them together we get 3. But now we're adding 3 and 1, not 3 and 2 because the order is the wrong way around. So 3 and 1 would give us 4, 4 and 3 would give us 7. There's the first 5 Lucas numbers. What we're really interested in are specific types of patterns, what are known as arithmetic ones and geometric ones. So arithmetic sequence, a sequence of numbers where it's found by adding a constant amount. Okay. That constant amount, the symbol, the common difference, we give D. D is the difference. So the common difference, if we wanted to work it out, I could get the second term, subtract the first term, that would tell me the difference between the two numbers. Or I could get the third term, subtract the second term. In fact, if I wanted to write a formula, I could get any term, subtract the number before it. That will give me the common difference. That allows me to create a recursive formula. So term n would be term n minus 1 plus the common difference. There's our recursive formula. But we can create a general term by doing it this way then. Let's create that pattern. First term we said was A, it's always A. So the second one would be A plus D. Third one A plus 2D, and pretty quickly we can see what's happening here. And to generalise it, we'll get A plus n minus 1D. So I'm told that the third term is 9, the seventh term is 21. What would be the formula to create this pattern? If the third term is 9, then I know A plus 2D is 9. And if the seventh term is 21, then I know A plus 6D is 21. Pretty much just simultaneous equations now. I just got to find what A and D are. So let's solve these simultaneously, eliminate the A, we get that D is equal to 3. Sub back in, I get that A is equal to 3. So the general term would be 3 plus n minus 1 times 3. Well, we can make that a lot neater. Let's expand out and simplify. We're simply talking about the multiples of 3 here. So our general term is 3n. Let's find the 100th term. Well, now I sub in what I know. They're just multiples of 3. 3 times 100 is 300. What would be the first one bigger than 500? So in other words, when is term n bigger than 500? When is 3n bigger than 500? Well, solve it. N is greater than 503. Now obviously there's lots and lots of answers. We want the first one. But it's got to be the first integer, because n's a whole number. And that would be 167. That would be the first whole number bigger than 500 on 3. So how do you write the answer to that? do you say, oh, it's the 167th term, because they said, what's the first term? Or do you say, oh, it's 501, because that is the 167th term? Wow, easy way to solve that is to say both. So it's term 167, which is 501. That's the first one, bigger than 500. If you were to plot on the number plane, you would find a linear function. To plot every solution, like n versus term n, you would get a straight line.